reporting. So mobility in space can be accomplished in a discrete environment by moving people between cells, and in a continuous environment by moving people to their destination in a continuous sort of way, typically. Any questions about mobility before we go on, particularly the project? Yeah. Okay. So the bug was, thank you for asking, because some people have come in since I mentioned it. The bug was a subtle one. It was one that I've encountered a couple times. Kirk encountered it, and you occasionally get hit by it. It's based on a subtlety involving any logic that we're knowing things. So when agents get created, so when any logic runs, agents get created in it, right? So you have these agents, and they come into being, right? They get given properties, for example, their home, their birth date, and then various other sort of aspects of them are determined as well. For example, their school is chosen, or their workplace is chosen, right? The subtlety has to do, what's the ordering here? In other words, are these parameters determined by the time this variable is determined? So we were picking the closest school when they came into being. And it was my tacit assumption, incorrect, it turns out, I wasn't thinking about it thoroughly enough, that by the time the closest school, this variable, received its so-called initial value, which we had an expression, we actually had it finding the closest school here. I was thinking that all these things were determined by them, and their x and y locations were set, their position was set. And that allowed us, my incorrect thought was that allowed us to say, their school is this dot, get nearest agent main dot school. This is what we had in there. So we were trying to determine what's their closest school when they came into being. The problem is, this was actually determined before the agent's position was determined. All of this is determined when they're coming into being, and it so happened this was computed before they actually had an x and y location. And so they were saying, what's my nearest school? When they didn't have a location assigned to them yet. Later, their location was assigned, but by that time, the school had been chosen. It was chosen based on incorrect location. It would be, I'm less good with real world analogies, but it would be someone as if you didn't yet have a place to live within Los Angeles, and they've already assigned you, the post office you want to go to. You find a house, and now your mailbox to the post office, what do they call it, fixed mailbox that you go to, is assigned way across town, or they've assigned you a phone number that's for a different area code because you weren't just so ready to be living. So in this case, it chose the school before we had a location, and so we found the nearest school to a meaningless location. By the time we had a location, our school had been determined, and we were going, in fact, everyone's initial location until it's assigned is 0. That's the origin. That's why everyone's being given the same school to go to. So that was the bug. We shouldn't have been doing it here. And the solution to it is simple. The solution to it is to say, okay, make their initial school. We're going to not have any initial school. We're going to assign the initial school when they come in here. So when they come into the state chart, just when they come in here, I know that everything has been set for them. Their x and y locations, all of these things have been set. And so that's one of the two things here. It's when they come in here, every school. And that's and that's the strategy for reducing So if you're gonna determine a variable in your model, you might think carefully about maybe you want to do it when we first start up this This is the subtlety. There is an order in which things get done. I actually forgot when I was doing this what the order was. The variables were actually determined before X and Y location. And it's a rookie mistake on my part. But easy way to avoid it is to just do it right here. Does that make sense? Yeah. Okay, so that was the solution to it. Boom. That's a one-line thing, but it fixed the problem. Okay, so any other questions? Just go ahead. Sure. So, I'll just narrate this so that people have an understanding, because some people came in. I also rearranged this to be clearer. So the idea is that once you're at home for 16 hours, then you go to one of these two places, home or school. And which you go to is based on your age. So this says go to institution, you should say go to school. And so you either go to school or you go to work. You go to work, so this would be go to work, right? You go to work if your age is greater than 18, and in that case, you would move to your workplace. Does that make sense? In that case, you move to your workplace. Otherwise, if your age is less than 18, you're going to take this default path down here to move to your closest school. And that's just the default. If this condition is not true, by extension, you are a child, and you go to school. So I would argue this is clearer than the previous one we had. Where you go to institution, you have to figure out, am I in a school or am I at work? If you make people visual, and it's clear. Less than 18, you go here. Greater than 18, you go there. This way you go to your workplace. This way you go to your school. It's all clean. None of it is declared agent. It's your destination. For the birds, if you can avoid it, it's much better to do it like that. Yeah. That's basically, you spend 16 hours at home. And now you have to choose, okay, I'm leaving home. Where am I going? And that's based on my age. Does that make sense? Yeah. Yeah. You can have 2 branches. You can have 10 branches. Right. I believe you, okay, in many cases, the conditions on the branches are mutually exclusive request is exhausted. So that you'll have, one to handle people who are 0 to 4 years of age, next 5 to 9, next 10 to 14, and that sort of thing. And there'll be successive branches that will handle each of those cases accordingly. And you can have as many branches as you want for that. Occasionally you'll see cases, there's nothing that enforces that here, so you'll notice that here this condition, it doesn't by its nature sort of enforce that they are collectively exhaustive, right? And mutually exclusive. So you could actually write something that wouldn't be terribly sensible, like just you go to that one if age is greater than 18, and you go to this other one if age is greater than 15, and it leaves open question if you're 30, which one do you go to, right? And I couldn't tell you with complete clarity which one is taken, but I will bet you how it's determined. And in other words, kind of up to you, but if you leave it to chance, my guess is it will be chosen arbitrarily based on characteristics, and I'll tell you what that characteristic is. I bet it's the order with which you've added these different transitions to the model. So the one that's added first probably takes precedence. That's the one that's examined first. I'm just guessing from other things I've noticed, but fundamentally it's up to you to make sure that you've got the logic sound about that. And if you leave an ambiguity like that, you can expect that it will choose for it to be which one it does. Does that make sense? Yes, you can. That's what it boils down to. Fortunately, in most cases, when you have multiple conditions, they tend to be collected as options exclusive, and you can specify the conditions for that. Does that make sense? Yeah. Occasionally what you'll see, back in that model I showed this morning, that model with TB, I don't know if any of you picked this up, but if you actually looked at this, one of these slides, do you see this? This is actually a situation where you have a cascading hierarchy with these branches. So first you determine if you're greater than 40, you're less than 40, and then you're doing that, less than this age or greater than that age, and in that case it's all text binary, and that can help allow you to use only one condition and then false otherwise, and lessen the risk is the sort of thing we're asking about. So that's an option with some smaller too. Other questions? Other questions? Oh, sure. So the way in which we define closest to school, it's defined coming into here, because by this point, by the time you enter the safeguard, you're guaranteed to have all your parameters set up, all your X and Y locations set, all that sort of stuff is good by that point. And what I do is when you come in here, I set the velocity so we go reasonably fast. We're not spending years driving. And then we have close to school equals the exact same thing we had before. This get nearest agent, so among all schools, what's the nearest agent to me? To me. That's it, me. Hey, me. What's my nearest agent among all of these schools? And it will return school. And that's our next sort of school. Does that make sense? Correct. 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 This was random, so it didn't depend on my location, but probably for consistency and just kind of to lower the cognitive burden of wondering where things are, we could have gone something like this: chosen workplace equals this. Right? And then you sort of know, okay, you should look within both. Better yet, you get the function, call function, so initialize definition, and then it gets the function to be clear and give the function. That'll be the thing. Okay? Other questions? Great question. Yeah. Right. Yeah. Right. Exactly. Yeah, great point. And I love that. So this would be 18 times year. And what that would mean is if at a later time I wanted to go up here and say, well, I'd really like to measure things in days or weeks instead, because I want my graph to be, according to that scale, then things would still work. So that's a nice use of that. Right. So that minus 65 to 0, really that. Nice point. I really like this. If we were to go back, not to home, to main, and we were to go look at the initialization for this, really this should be minus 65 times year. And whatever yardstick we use to measure time, the model will still work now. And I could say 0 times here if I wanted to, but really zero is zero for any of those units. So that would be a little bit optional. But yeah, that's a very, very nice point, and actually a nice feature. I think I'm over this. That's it. That's what adds clarity to this. So that's good. Other questions? Okay. Maybe I won't actually do it, but I just want to comment because it's so close to many of the models, and I don't want it to get submerged in the discussion here of the plumbing of the model. This structure here that we see, particularly distinguishing work and school, it would allow you to do some pretty useful things in terms of figuring out the impact of the school environment or of the work environment on this person. So this is a child going to school, or a person going to work. And it's in these states here, the work and school states, that presumably you could insert logic that would say, okay, what's the nature of the school environment? How healthy is it? And given that they're, unhealthy in this way, or given that there's high sodium diet at work or what have you, how am I affected? And so presumably there'd be some sort of space here or some sort of memory. Maybe it's your cardiovascular health, maybe it's some aspect of your awareness of nutrition issues or what have you. But there'd be some aspect in person that reflects kind of their knowledge or their physiology or what have you, and that in these states would be affected by your environment. So this captures kind of the fact that you are in a school environment while you're here, and you're then modified by that school environment. You've been influenced by that school environment. Swimming up at purple. Up at that, when you're in the work environment, you are being influenced by the school environment. So that's where you have the logic that I'm being modified. My condition is being affected by that environment. My attitudes, my beliefs, my norms are being affected by that environment. And then you come home and you're modified by that home environment in some sort of way. So, while a lot of the discussion today was on plumbing of this sort of model and bugs and ways of calculating things, ways of expressing things, this general structure is a very general mechanism for capturing environmental exposure on the part of the person. It would afford an economy of sort of expression for capturing influences on these 3 different environments that might be incident on a person, and would moreover be capturing aspects of aging in the process. Maybe just to bring home this point, I'm going to replace that person's little depiction that way, and instead replace it with with my favorite depiction, and this will emphasize the fact that we are seeing dynamic processes as a part of an individual as well. So here's this individual, and we might have the radius of this be dependent on their age, for example, get age, right? And we have to set this. There we are. Okay, let's get rid of this guy. Fine, and then switch this to get age. And so if we change this over time, let's see if it's the right. Okay. Whoa. Okay. That looks a little bit entropic. So let's go try that again. We'll make it get age divided by something. Okay. So it's the oval. make it get age divided by 10, something along those lines. They'll start small and get larger. Yeah. So here we have a population of individuals. They're going to school. You notice the schools are associated with smaller little blips, and then they're going back to home. So I'm going to slow this down. But the point is, people here are aging over time. Those circles are slowly growing, and that's sort of representative of the aging process that's occurring at the level of each individual. So the population as a whole is aging here, hence the sort of ages associated with these workplaces, etc. There's no one going to school now because everyone's aged out of it. So there's evolution going on here at the part of an individual, and really what will be incumbent upon a group that's interested in capturing environmental influence will be to keep track of some sort of variables having to do with exposure, some sort of measures of sort of the physiological impact or the psychological impact of exposure to this environment. Are there any questions about that? This is at the level of an individual and add basically variables for them. Okay, good. So I think that concludes sort of our discussion.